Hello, today I'm going to talk to you about a mole and Avogadro's number, which is the number of things in a mole. So the mole is just a quantity, just like if I were to say that a dozen things is 12 things, all right, that's true no matter what you're counting. If you have a dozen eggs, that's 12 eggs. If you have a dozen donuts, it's 12 donuts. A mole is the same, except one mole of things is 6.022 times 10 to the 23rd things, all right, so that's a lot of things if you remember back to our scientific notation. That means that we'd have 6 and then the 0, 2, 2, and then 20 more zeros to make that number. So it's a very big number. And it's named after Avogadro, who was a scientist that did work with gases and figured out that a particular number of gases had a set volume. All right, so this is the number, 6.022 times 10 to the 23rd. And like I said, it is the same whether you're talking about molecules or atoms or elephants, all right? That's how many things are in a mole. But normally we're talking about things that are very small, like atoms or molecules. So if we want to write it as a conversion factor, like we were doing in the previous lesson, that would be 6.02 times 10 to the 23rd items. Could be atoms, could be molecules, could be ions, could be basketballs. In 1 mole, or 1 mole is 6.022 times 10 to the 23rd items. Okay, sometimes you'll see this is just 6.02. It's just a fewer significant figures, but it's the same. Okay, so now how would we use those? That number in a calculation? So let's start with a dozen because I feel like we have a better sense of how big that is. So if I were to say, okay, I'm making cheese sandwiches. 1 slice of cheese and 2 slices of bread makes my sandwich, okay? So how many cheese sandwiches are in 2.5 dozen sandwiches, right? So you're just going to use the quantity 12 sandwiches in 1 dozen, okay? And if we have 2.5 dozen, that's the number that's going to go on the front. The 12 in 1 is always going to be our conversion factor. That's always how many things are in a dozen. And then we would just multiply. 2.5 times 12 is 30 sandwiches. Okay. Now, if we wanted to know about how much cheese we were using in our sandwiches, we would be doing the same thing, except we'd add an additional step to get from sandwiches to slices of cheese. Okay. So 2.5 dozen sandwiches. 1 dozen is 12 sandwiches, and each sandwich has 1 slice of cheese. All right. So we're just using these ratios that we know from up here for our sandwich recipe. Okay. So that's 30 slices of cheese. And now if we did the same thing for bread, it would look just a little bit different. The first part would be the same, still 12 sandwiches in a dozen, right? But we have 2 slices of bread in each one of our sandwiches, so it would be 60 slices of bread for 2.5 dozen sandwiches. All right, so now let's go ahead and do this using the mole, all right? So if we know that 1 water molecule, which is an H2O, has 2 hydrogens and 1 oxygen. All right, that's our ratio, just like the cheese and bread was in our previous question. So how many molecules of water are in 2.5 moles? So 2.5 moles is still going to go right out in the front. Okay, we know that 1 mole is 6.02 times 10 to the 23rd molecules. Okay, this is where you would use that EE button on your calculator to put it in to do the calculation, and then you'd get 1.5 times 10 to the 24th as the number of water molecules that you had. All right. If we want to know about how many oxygen atoms, the first part is the same, right? But then we look at our formula and see, okay, we have 1 oxygen atom in every molecule, okay? And so we'll get that same number because each molecule has 1 oxygen. Whereas if we do the same thing for hydrogen, you'll see that we have 2 hydrogens in every molecule, and so we'll have a 2 here at the end. That's our ratio, 1 molecule equals 2 hydrogen atoms, and so that will give us 3 times 10 to the 24th hydrogen atoms.